In April 2026, something extremely rare happened in the Pacific Ocean that could potentially alter the course of history. Twin cyclones formed on opposite sides of the equator, disrupting the trade winds and setting off a chain reaction that may just trigger the strongest El Nino in over a century. Reports of a coming super El Nino began flooding the media, along with comparisons to likely the strongest one ever recorded in 1877. By some accounts, the 1877 El Nino reshaped the world politically, and it's been described as arguably the worst environmental disaster to ever befall humanity, killing over 50 million people, or 3% of the entire world's population at the time. I mean, how is that even possible? Well, today we're digging into what really happened in 1877. And because this year's El Nino is playing out in a completely different world, I wanted to know if the 1877 El Nino really was that devastating. Could something like that happen again?
When you have climate shocks, those are not happening in isolation. They're happening over everything else that we are experiencing in the world right now.
First, what exactly is El Nino?
El Nino Southern Oscillation basically refers to fluctuations in sea surface temperatures in the tropical Pacific.
This oscillation swings between La Nina, cooler temperatures, and El Nino, warmer temperatures. Under neutral and La Nina conditions, trade winds blow from east to west along the equator. They push warm surface water towards the western Pacific, while colder, deeper water rises in the eastern Pacific, a process called upwelling. This creates a huge temperature contrast across the ocean. Warm water in the west, cold water in the east. And that contrast helps drive something called the Walker circulation, a giant atmospheric loop over the tropical Pacific. That warm pool in the west fuels rising air, clouds, and rainfall, while cooler, drier air sinks over the eastern Pacific. And this circulation reinforces the trade winds. So under normal conditions, the tropical Pacific is engaged in a feedback loop. The winds shape the ocean, and the ocean helps keep the winds blowing. But every so often, something disrupts that system, like those twin cyclones in April.
For a few weeks, there were no trade winds. The winds were blowing opposite thanks to these two cyclones. And that kicked off this monster Kelvin wave that we are still seeing in oceanographic measurements. And that's the early stages of an El Nino.
Without the wind to push it west, that warm surface water can spill back to the east in the form of Kelvin waves, massive, slow-moving pulses of warm subsurface water. And they are the first signal that experts look for when predicting an El Nino.
We need several of these fluctuations and individual Kelvin waves for the system to fully engage.
When that typically cold section of the Pacific rises by at least ½ degree Celsius for several months, we're officially in El Nino territory. But it doesn't have to stop there.
Maximum temperatures at small locations can sometimes reach up to 5 degrees centigrade above normal in a really, really big El Nino.
And that massive release of ocean heat actually heats up the entire planet. But this swing happens fairly regularly, every few years. So how do we go from a regular El Nino to an extreme one? In the most extreme cases, as the warm pool shifts east, it drags that column of heat and convection along with it until suddenly the Walker circulation is flowing in reverse. This sends ripples through the jet stream and completely reshapes global rainfall.
Invariably, the Amazon dries up. Thailand, Cambodia, Vietnam get these massive heat waves during April. El Nino suppresses hurricane activity in the Atlantic, but it enhances hurricane activity in the eastern Pacific off of the coast of Mexico.
So this is how a patch of warm water in the Pacific can become a global weather event. And to see the dire impacts, all we have to do is take a step back. Over human history, we've seen plenty of strong El Ninos, like in 1982, 1997, and most recently in 2015. But out of all of those we've recorded, the one from 1877 to 1878 was likely the strongest.
We have sea surface temperature measurements from ships that go back to 1856. There are ways of filling in the gaps using modern satellite records.
Based on the data sets that we analyzed, the 1877 El Nino event was strong stronger than the most recent El Nino events on record.
Remember that 0.5 degree benchmark? These models suggest in 1877 it may have gotten as high as 3.5 degrees above average. And this, along with some other unlucky factors, triggered what historians call the Great Drought. The spike in temperature lasted for a devastating 16 consecutive months, suppressing 2 summer monsoon seasons.
South Asia, Southeast Asia, West Africa, Central America, those are all part of the global monsoon system. And many of these regions experienced consecutive droughts, which resulted in food shortages. Those translated into famines. They killed over 3% of the global population at the time. So that's about 55 million people.
Clearly, this was a monumental shift in global weather patterns. But even so, how could it have wiped out over 3% of the world's population?
India and China had dealt with droughts for centuries. The leaders of those nations had policies in place to store grain, so they rarely ever led to massive famines.
To create a famine this large, El Nino, even a record-setting super El Nino, needed a multiplier. For many regions in the 19th century, that was European colonists and the rapidly expanding British Empire. In India, even as drought led to widespread crop failure, the British government continued to collect taxes and export grains. Food became completely unaffordable to the very people who were growing it.
It was an artificial food shortage that was created because of the political environment at the time.
In China, the worst drought in 300 years hit at a terrible moment. The Qing dynasty had just endured decades of war, and the systems meant to keep people alive, its treasury and grain reserves, had been pushed to the brink of collapse. And though China wasn't colonized, Britain played a role here too.
Britain was exerting control over trade across the whole region. These were the first major El Nino-induced drought that led to mass famine, because whatever grain was being produced was still being exported, rather than some of them being set aside to get through potentially years of drought.
Mass starvation rapidly swept through both countries. By 1879, the death toll likely exceeded 12 million in India and 20 million in China. And during this catastrophe, the British Empire didn't just multiply the impacts of El Nino. The Super El Nino created an opening for the British Empire to exploit and expand.
The impact that people were facing in many regions was used as a reason to invade those areas.
This happened at a time when the British were trying to take control of what became South Africa. And this El Nino event came along and they defeated the Zulus, who were greatly weakened by the ongoing drought and famine. That led to British control of that region for quite a long period of time afterwards.
In fact, the system of separation that the British created set the stage for the more codified apartheid decades later. Similar stories played out in Southeast Asia, Australia, parts of South America, the Mediterranean, and across the continent of Africa, culminating in over 50 million deaths. So yes, the strongest El Nino on record did lead to the death of around 3% of the world's human population. But all of this leads back to that one central question that I have. Could something like that happen again? Well, thanks to the existence of modern agriculture, trade, and emergency relief, we simply don't see famines on anything like the scale we used to. And we have an unprecedented ability to transport and distribute food. But after global deaths from starvation plummeted 99% during the last century, we've seen a sudden reversal in that trend in recent years, caused by conflict, climate, and economic shocks. Forecasts now suggest that this year's El Nino could be stronger than anything in the historical record, potentially far surpassing even the 1877 event. And today's politics do echo the stressors of 1877.
We have several wars going on. Most nations are not in very good relations with other nations.
Today, the global aid system is facing unprecedented cuts, with the dismantling of USAID as the most prominent example. Researchers estimate those cuts have already contributed to hundreds of thousands of deaths and project that USAID cuts alone could lead to more than 14 million additional deaths by 2030.
What worries me most is that there are already communities facing high disease risk, high food insecurity. Those impacts are likely to be amplified during an El Nino event. And we're also seeing the time between disasters reducing. If people haven't recovered from one climate event and then they experience another one, their capacity to adapt is weakened.
And on top of all of this, the systems that we rely on to see these disasters coming could get worse as well, as cuts to federal weather, ocean, and climate science agencies threaten the data, monitoring, and forecasting that help communities prepare and respond. So, will this El Nino look the same as it did in 1877? Likely not. But that doesn't mean it won't have disastrous, world-changing consequences.
Ultimately, what matters is not how strong the El Nino is. What matters is how strong the impacts are around the world. We can allocate resources to places that we think would need them because we know that the impacts are likely to be severe.
So what do you think? Are we taking the threat of this coming potentially very strong El Nino seriously enough? And if we can see some of these impacts coming, what should we be doing now to prevent the worst? Let me know what you think in the comments. And before I go, I just want to thank you guys so much for checking out this episode. Our audience is really what makes stories like this possible. So if you value what we do here at Weathered, please consider joining our Patreon. Every dollar you contribute allows us to continue to produce well-researched and fact-checked stories about our ever-changing world. Thank you so much, and see you next time on Weathered.